Find the volume whose base lies inside the cardioid, r equals 1 plus cosine theta, and outside the circle, r equals 1 in the xy plane. The volume we're looking for is bounded above by the plane z equals x. So what we really have is a cylinder that's not a circular cylinder, right? So I have a region in the plane. That's r equals, on the outside, r equals 1 plus cosine theta, which is a cardioid. And then the region in the plane's bounded on the inside by a circle of radius 1. This reminds me of a region we found the area of earlier, but it was a little bigger. All right, and then I imagine this forming a cylinder that stretches out, but I'm cutting it with the equation z equals x. So if I imagine the z-axis coming out of the board, it's a plane that's kind of coming through the board like that. So I have this cylinder, and I chop it along the plane z equals x. Well, I should be able to set up a double integral to find that volume, except for I'm thinking it needs to be a polar integral because, you know, everything here in the base is nice and polar. So the dA becomes an rdr d theta, and I need to convert z equals x into z equals some function in r and theta. Well, fortunately, that's not too bad because that's just x, which is r cosine theta. So I'm ready to set up my double integral. The function, r cosine theta, and then that rdr d theta. And then r dr d theta, I'm just going to go and make that an r squared dr d theta. Well, looking at our region, I enter the region at the circle and exit at the cardioid. And then I can see that my bounds are minus pi halves all the way up to pi halves. All right, so now we just need to go through 2 rounds of integration to see if we can find this volume. So I first integrate with respect to r. So I need to cube this times cosine theta minus 1/3 cosine theta d theta. All right, so now I need to multiply some things out, combine some like terms, and then I'll have a integral in one variable that just has a bunch of powers of cosine. So I need to multiply out 1 plus cosine to the 3rd power. So I'll have a 1 cubed plus 3 times 1 squared cosine, so 3 cosine theta, plus 3 times 1 times cosine squared theta, plus cosine cubed. And all that still times cosine theta, and I still have a minus 1/3 cosine theta hanging out here, all d theta. All right, let's see if we can combine some things up, distributing and combining. So I'm going to distribute the 1/3 and the cosine theta through here. All right, so all the powers of cosine went up by 1. And everything got divided by 3, and then I have that minus 1/3 cosine theta d theta. All right, Well, that 1/3 cosine theta minus 1/3 cosine theta, at least those cancel out for me. All right, and so now I have an integral in one variable that only requires me to take the antiderivative of a bunch of powers of cosine. So here I would use a power reducing formula because I know that cosine squared theta is 1 plus cosine of 2 theta all over 2. Here I would rewrite this as a cosine theta times cosine squared theta. You can use a clever substitution after you do that. And then finally, you can use power reducing formulas here as well. I'm going to let you proceed on your own because everything from here is really part of a Calc 2 class. Below the link to the video on our Moodle page, you'll find my solution from here to the end.